Hello, I've had in Unit 2, lesson number 7, I've had an excellent question about the negative sign with elastic energy. And the question that I'm addressing here is, when do we drop or why do we drop the negative sign? And how do you know when? And then what is the purpose of it? So I'm going to try to answer all those questions because it's an excellent point, and sometimes it looks like I'm playing fast and loose with the negative sign, and I'll explain the why as best I can. So we know that, if I give myself a quick sketch here, we know that we know our work formula is force multiplied by displacement, which means that energy, which is just work, is the force we apply to a spring multiplied by delta x. So if I put delta x on the x-axis and I put force on the y-axis in newtons and in meters, we know that, and I'm going to use multicolors here, we know that a spring in its natural state has a natural rest position, which I'm going to mark as my blue here. If I compress the spring, I'll do the red, so we squish the spring down to that point right there, or if we are to stretch this spring out a little bit more, what happens is, in both cases, we have stored energy. So we have our compressed area and our extended area. And if we assume that the natural rest position is our zero in terms of extension, if we were to do an experiment with that and graph it out, the resulting graph would be a line, okay, that would show the amount of force in either direction required to compress or extend the spring. And that's why the formula then that comes from that is, the elastic energy is negative 1/2 k delta x squared, and it's from the fact that the k will have a negative slope. So that's where the negative will come from in that equation. Now, if we look at in terms of compressed energy, so if we're looking at compression, our elastic energy will be negative 1/2 k bracket negative delta x squared. So we have moved down the x-axis to the left, which means we've moved in the negative direction. So we've compressed it in a negative fashion. We get negative 1/2 k, and when you square it, it becomes a positive again. So we end up with delta x squared. And if I do the same thing for extension, elastic energy equals negative 1/2 k, and this time it's going to be positive delta x squared, because I would be moving it in the positive direction on the delta x axis. We end up with the exact same result. So why is that? Why are we ending up with the exact same result, or what does that negative really mean? Well, that negative sign that's appearing in both simply means stored energy. Okay, so it means stored energy. When you compress a spring, the spring has the ability to push outward or expand, which means it's stored potential energy. If we extend the spring, that extension part, the spring wants to return to its natural equilibrium, it also has stored energy. So that negative sign indicates that we have stored energy. So that's what that negative sign really indicates in the equation. All right. What gets confusing is when you want to apply it to a situation. And the example that I was looking at was from the note, and it's specifically C part. Okay. So in C part, what's the speed of the block as it returns to equilibrium position? So this spring was it stretched or compressed? The block is pulled out, so it was extended. So if this was my original spring, and then in C part, it got stretched, it has stored energy. So if we were to calculate that out, we would have elastic energy equals negative 1/2 k delta x squared. However, in this case, we know this is stored But when we want to go and answer C, we take that stored elastic potential energy and we are going to convert it into kinetic energy. And that arrow really becomes an equal sign because we want to know if all the elastic stored energy is transferred to kinetic energy, what will the resulting velocity be? So at this point, this is why I dropped the negative sign, because it's no longer stored. Over here, we're talking about it from the aspect that the spring has been stretched. We have this much stored energy. Now, when I go to a word problem or an application question, and I'm going to let this spring go, this is how much useful energy I now have available to convert to kinetic energy. So I drop my negative sign now, because now I'm saying, okay, all that energy is now going to be useful energy. It's going to be converted. So the negative sign is only really an indicator telling a viewer, telling someone that's reading a solution, oh, this is stored energy. Once I want to use it for any of my equations, I switch it to kind of the absolute. I think of it as an absolute value because this is the useful energy that is part of this particular system. Okay, so remember, it's just the negative indicates it just indicates that it's stored energy. It's similar to in grade 11 physics. If this was the ground level, there was the question: if you go up an elevator 10 meters high, what's your new energy? Well, EG would have been mgh, which would have been m times 10 times 10. So you would have had 100 times your mass joules of energy. B part would have been, what happens if you went down in the basement instead? What happens if you went 10 meters down into the basement? Well, your new gravitational potential energy, mgh, can now be m times 10 times negative 10, because this is my reference point. All right? So we end up with negative 100 mass times energy. So it indicates that we've moved to the opposite side of our reference point versus on the positive side of our reference point. The difference being, you can't store energy with a height difference. So it never really came up in the grade 11 course. With springs, they have the ability to store that energy if they're stretched or compressed. Now, I'm hoping I hit on and answered all the questions I've kind of point formed out here that were asked. So the negative sign itself, if you are doing a pure calculation on a spring, how much energy will a spring have if it's stretched, blah, 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 something along those lines, you will have your negative signs. So you will use negative signs when the question is just specifically about spring or elastic energy. If the question then extends to how much kinetic energy is going to come from this, or so on and so forth, then we got to look at it in terms of the useful energy. So that's how you know to all of a sudden drop that negative sign, because that energy, we don't care that it's stored energy, it's the energy that's useful or available to be in the system. So that's how you know when to drop the negative sign. All right. If you were to keep the negative sign in this instance here, so let's, for argument's sake, say you kept your negative sign. Your 1/2 would cancel, and if you're looking for a velocity, what will happen is that you're going to get v squared equals negative k delta x squared over m. Then you're going to try to take the square root of that, and you're going to get an error. All right, and the error is because of that negative sign. So and this is why I always tell people, even when you're doing how much energy is stored, I'm not a big fan of keeping the negative sign, and that's the engineering aspect, or my perspective coming out, because I have an engineering perspective. I already know it's stored energy, okay, because I am stretching or compressing a spring. So if you were to drop that negative sign altogether, the assumption is the stored energy is 30 joules. Well, we know it's stored. It's not like it's a mystery to us. We understand that, and that's all that negative sign tells us. The problem, the reason I always tell people to ignore the negative, is because they get into this situation saying they can't solve the equation, when this negative sign right here is the culprit, and really it was just originally telling us that we had our stored energy. So I'm hoping that that makes sense. If you report all your energy without that negative sign and just say that it was 30 joules of stored energy, that's as good as keeping that negative in there. If you plan on going to pure physics course, obviously they're going to be a little bit more strict. If you go into an engineering program, it's more of a practical approach in terms of, yes, that's what the negative means, but you know what? It really causes us mathematical problems later on. So I'm hoping that answers the question that was asked and provides a little bit of clarity. If there's any other questions, please make sure you ask, and I'll do my best to answer or clarify them.